This Earth has only one natural satellite, but we have made do very well with this, our lone moon. It is interwoven in man's history, its waxings and wanings long ago recorded on calendars. What now compels modern man to fly to the moon? There is the great urge of discovery and exploration, for exploration has always opened new, unexpected horizons to our view, and opened undreamed of frontiers of economic development, technology, and social well-being. But in setting foot for the first time on this heavenly body, we are not simply discovering a new chain of mountains. There is a greater opportunity before us. The moon is a vast natural laboratory existing much as the Earth did billions of years ago. For the moon is without an atmosphere. It is without weathering and erosion, two forces which have reworked the face of the Earth and obscured its remote past. It is a laboratory we could never build with all our hands and all our tools. We can fly scientists and scientific instruments to this laboratory. We can study the origins of the Earth and perhaps of the universe. A flight to the moon in the space age is not long. 2.5 days to travel back in time 5 billion years. This is a voyage of exploration that man must make. We cannot draw a straight line from the Earth and fly along it to the moon. The moon is moving around the Earth at 2,300 miles an hour. The Earth is revolving around the sun at 67,000 miles an hour. Both are revolving on their axes. We must fly between 2 points constantly changing in space. For the manned flight, we have chosen a free return trajectory to the moon. This means that the spacecraft is fired from orbit to the moon in such a way that it will loop around the moon and return without further power being applied. Normally, of course, we will insert the spacecraft into orbit at the moon's equator and land at a pre-selected site. We choose a launch time and trajectory so that the crew will land in daylight. The sun will strike the site at an angle of 7 to 20 degrees. This gives the crew visual perception to avoid obstacles when landing. Preparation for launch will begin here, the Vehicle Assembly Building at Kennedy Space Center. A vehicle assembly building provides protection against the weather during most of the pre-launch checkout period. It is almost 44 stories high and tall enough to check out an Apollo Saturn V space vehicle on its mobile launcher. The assembled space vehicle travels to the launch pad 3.5 miles away on a transporter crawler. This is the command module, living quarters of the crew. The mission commander is in the left couch. His crew, a command module pilot in the middle couch, and a lunar module pilot to the right. The command module contains all systems critical to piloting the flight once the spacecraft leaves Earth orbit. The second unit is the service module. The service module contains a large propulsion engine. It takes over after the jettison of the big booster. We carry 2 spacecraft in a lunar mission. The second is a lunar landing spacecraft, or lunar module. It has separate descent and ascent stages. Below the lunar module, an instrument unit carries a computer and associated electronics. It guides the spacecraft into Earth orbit and computes the trajectory to the moon. The launch vehicle is composed of 3 boosters, plus the instrument unit. Together they are called the Saturn V launch vehicle. Saturn V will launch into orbit 40 times the weight of Gemini, 85 times that of Mercury. Final countdown for the Apollo Saturn space vehicle is conducted from the Launch Control Center next to the Vehicle Assembly Building. At T-minus 30 minutes, the launch escape tower is armed. From this point until it is released at slightly more than 50 nautical miles, the launch escape tower would be fired for emergency escape, carrying the command module to safety. The spacecraft is not launched directly for the moon, but into Earth orbit. The first stage of Saturn V propels the spacecraft to 34 nautical miles altitude and is jettisoned. The second stage takes over. Then a structure between the first and second stages is jettisoned. In this period, too, the launch escape system is jettisoned. From now on, the crew can fly the spacecraft safely back to Earth if necessary. After the second stage is jettisoned, the third stage takes over and inserts the spacecraft into a parking orbit 100 nautical miles above the Earth. At Marshall Space Flight Center, propulsion and stage experts monitor the performance of the launch stages closely. The flight is not yet 12 minutes old. The third stage shuts down, but we retain it in orbit and will use it yet once more. So far, we are on very familiar ground of manned flight, but we are preparing for the unfamiliar. The crew completes their in-flight checkout. If all systems are now go, this man, Flight Director at Mission Control Center, Houston, will commit 3 pioneer astronauts 250,000 miles into space. The decision is made. Over the ocean, the third stage is fired for 5 minutes, and man is on his way. The crew will have little time to reflect on this fact. For 15 minutes later, protective panels will open as the command and service modules separate from the lunar module. Using the service module control jets, the mission commander turns around. He completes his maneuvers and docks with the lunar module. The third stage and instrument unit are jettisoned. The flight to the moon is now in a coasting phase. Velocity in space will average 3,300 miles per hour. The mission commander will navigate, taking star readings as a backup to ground computations. Mid-course corrections from the ground will be made during the translunar flight to maintain the proper trajectory. Just before the spacecraft approaches the moon, the lunar module pilot will transfer to the lunar module and check it out. As the crew swings around the moon, the service module main engine is fired to reduce velocity and insert the spacecraft into an orbit 80 nautical miles above the moon. After a period of preparation, including sleep, the mission commander and lunar module pilot transfer to the lunar module. The command module pilot is left behind to fly the Apollo spacecraft in orbit. The lunar module is separated. 2 automatic firings of its descent engine lower it to the immediate landing area. The mission commander takes over the controls for the touchdown. He carefully brings his spacecraft to a safe landing. But no one opens a hatch and leaps out. The crew must check the lunar module systems and put on special life support equipment. The outside temperature is about 200 degrees Fahrenheit. There is no oxygen in the airless atmosphere. The moment we have waited for comes. 2 Americans stand alone on the unexplored plains of the moon. Surrounded by the silence of billions of years, what will they say? The crew will explore the lunar surface, working together as a team. They return to their spacecraft to replenish oxygen, sleep, and eat. Total stay, about 24 hours. The crew will set up a series of experiments known as the Apollo Lunar Surface Experiments Package, or ALSEP. Once set up, it will look something like these scientific instruments being tested on a simulated lunar surface. The experiments will measure the charged particles of the solar wind, the magnetic characteristics of the moon, presence of ions, and seismic activity. A small atomic generator furnishes electrical power to the experiments. Once activated, a data collection station can transmit 1,060 data bits a second back to Earth and continue to send us this precise information long after the crew leaves. A very important task is collection of geologic samples. 40 to 50 pounds of lunar samples will be flown back in sealed containers. When the exploration of the moon ends, the crew will rejoin the command module. They re-enter the lunar module and fire the ascent engine. The descent engine and landing platform are left behind. The onboard computer will guide the lunar module into an orbit slightly lower than that of the command module. The crew makes the final approach and docks. The 2 exploring astronauts, with their lunar samples, transfer back to the command module. The lunar module is separated and left in orbit around the moon. The flight director at Mission Control will relay the necessary guidance information for the homeward voyage. The service module's main engine is fired, and the crew on its way. The trans-Earth trip is, of course, the reverse side of the coin to the trans-lunar trajectory. Mid-course corrections will be set into the computer from the ground, if required. After more than a week in space, the crew approaches the Earth. About 20 minutes before re-entering the Earth's atmosphere, the service module is jettisoned. Now, all that is left of the original space vehicle is the command module. We aim for a re-entry corridor about 20 miles deep. It begins with the atmosphere 80 miles above the Earth. The re-entry path will be controlled on board by the computer, but manual corrections can be made by the crew. Re-entry velocity will reach about 25,000 miles an hour. As the atmosphere slows the spacecraft down, the crew is protected from the enormous heat buildup by the blunt end of the spacecraft and by shielding around the entire spacecraft. At 10,000 feet, pilot chutes pull out the main landing parachutes, and the spacecraft is slowed to a safe landing speed. It heads for touchdown in the ocean. In one way, this landing is quite different from previous missions. A mobile quarantine laboratory will pick up the crew and take them direct to the Lunar Receiving Laboratory at the Manned Spacecraft Center. The crew will undergo a 3-week isolation period for debriefing and detailed observation. There is a very remote possibility of lunar contamination. The lunar samples will undergo preliminary study for 4 weeks, isolated against Earth contamination. Samples will then be distributed to distinguished foreign and American scientists. These scientists will apply their specialized knowledge for detailed analyses of the samples. Studies will continue for years. And the moon, which has been with us for 5 billion years, will begin to yield up its silent secrets. And this only a beginning. We will have demonstrated our ability as a nation to operate in space up to lunar distances. As for what lies beyond the moon, Saturn vehicles will have the capability to launch spacecraft to explore Mars, Venus, and other planets. The Apollo lunar mission is our beginning of the inevitable exploration of space.